Hello. Today we're going to look at trying to work with three equations and three variables and finding what are called ordered triples. Ordered triples means that you're looking for three unknowns, and instead of just a point like an x and a y, it's usually an x, y, and a z, i.e. the term triple. I put an example of that on the board here. Here we have three equations, and our three unknowns are x, y, and z. How do we deal with this? Well, let me just say right before we start, these can be very messy, and you have to work very carefully. It's a lot of work, and one small mistake will lead to terrible results. And just so you know, these type questions are designed to have whole number answers, integer type answers, not fractions and decimals. So if you get fractions and decimals, you know you've done something wrong. You should go back and double check your work. Let me show you the strategy we would use here. What we're going to try and do is use elimination and reduce this so that we have two equations with the same two unknowns. And so what I do first is I kind of look at my x's, and I see there's a 4x, a 2x, and an x. And then I look at the y's. I have a positive y, a negative 2y. And then I look at my z's, where I have z, two z's, and negative z. And I kind of look for which variable would be the least amount of work, the least amount of doctoring of equations to provide me with some elimination. I think in this example, I'm going with the y's. For, I guess, the obvious reason, I think if I add the top two equations together, the y's disappear, and there's really no doctoring required. So that's the first thing you want to do. And experience is your best friend on this. The more of these questions you do, the more you kind of know which will be the least amount of work for you, which route to go. So I'm going to go with the y's here. I could go with the z's. They look pretty good too. And you know, it's not wrong to go with the x's. It's just a little bit more work. So what do we do first? Well, I'm going to take the top two equations and just add them together. That's going to cause the y's to eliminate. So I'll end up with 4x plus 2x. So I'm going to have 6x. The y's will eliminate. And then a z plus 2 z's makes 3z's. And on the right side, 5 and 10 makes 15. So there's my top equation, or top two equations combined. Now here's a little tip as well. Each of these terms is divisible by 3, so there's no reason you can't make it even simpler by dividing everything by 3. So I'm going to do that. So this guy now becomes 2x plus z equals 5. So I'm just going to highlight that. That was using the top two equations. Now I look at my other sets or pairs of equations that I could use. I used the top two. I could use the first one and the last one, or I could use the second and the third one. And I guess it doesn't really matter. Probably the easiest thing to do is to use the first one and the last one. My goal, again, is to eliminate y. That's the variable I'm focusing to eliminate. So I'll give myself a little bit of room here. What I'm going to do, I look at the top and I look at the bottom here, is I'm going to multiply the top equation by positive 2, thereby creating positive 2y, which will eliminate with the negative 2y down here. So I'm going to take this top one here and multiply it by 2. So I'm going to have 8x. I'm going to have positive 2y. I'm going to have positive 2z. And I'm going to have 10. The bottom equation, I'm just going to leave that alone. So now what I'm going to end up doing, and I'll just rewrite it for clarity here. The bottom equation, as I say, I'm leaving it alone. X minus 2y minus z equals 2. I'm going to add those two together. That gives me 9 x's. The y's disappear. 2 z's minus a z, so that's 1 z, equals 12. And there's no number I could divide into all three terms, so that one's as simple as I can get it. So I'm going to write that one on the sidelines over here. So I've got 9x plus z equals 12. Now what I've done, just to sort of recap what I've done here, started with three equations, three unknowns. By combining and using some elimination on two and then a different pair of equations, I've been able to work this to get two equations with the same two unknowns, in this case x and z. Well, this is going back to a system of two equations, two unknowns, and we can use elimination, substitution to solve this. So I'm going to figure out what x and z are by working with these two equations here. Now I'm going to be needing a little bit of room here. And I think what I'm going to do is erase this part here, and I'm going to have to come back to it later, but I only have a limited amount of space to work with. So I need the space for working and solving this system. What I think I'm going to do is multiply this top one by -1. If I do that, then the z's will disappear. So I'm going to have -2x, -z equals -5, and on the bottom, 9x plus z equals 12. I add them together, that gives me 7x's. These cancel, and this becomes 7, so it turns out x is 1. So now I have one of my variables, figured it out. The other variable, the z, would be very easy to get from one of these two equations here. Perhaps I'll use the bottom equation, so I now have 9 times x, well x is 1, plus z has to equal 12. So I take 9 away from both sides, turns out z is 3. So now I've got two of my unknowns. How do I get the third unknown? I go back to one of my original equations. Remember, I had three equations with three unknowns. You pick the equation that looks like it's the least amount of work. I have the luxury of having the equations in front of me, and the top equation looked to be the easiest. So I'm going to use that one. And that equation looked like this. It was 4x plus y plus z, and that had to equal 5. That was our top equation. Well, now we know x is 1. So I have 4 times 1. Don't know why, but I know z is 3 equals 5. So what I have is 4 and 3 is 7 plus y is 5. So I take 7 away. Y turns out to be -2. And here's how you should give the answer. As I said before, it's called an ordered triple, and always think alphabetical order. We would list the x first, then the y, and lastly the z. So that is our ordered triple solution. It's the only combination of three numbers that make all three equations true if we substituted them in. Okay, and I think that's where I'm going to stop.